our very first theorem actually has a converse. This is to say it has a statement that can be written in reverse. And this converse reads as follows. It says that if the adjacent angles are supplementary, then these angles form a straight line. And we then write the short version of this theorem to be adjacent angles are supplementary. Remember that the short version of a theorem or a converse is actually the A part of the theorem, which basically is this first part of the theorem that says adjacent angles are supplementary. That's how we write the short version of a theorem. Now, this would be the A part. The B part would then be the conclusion that those angles must be sitting on a straight line. They form a straight line. Now, when we look at this in the form of a diagram, it would be a situation that we have lines that are drawn here such that they create these angles, angle O1, angle O2, and angle O3. And all these three angles are next to each other. That is to say, they are adjacent to each other. We further say that, or we know that when we add these angles, angle O1, which is that, and angle O2, which is that, to angle O3 as well, which is that, they give us 180 degrees. They are supplementary. What we can conclude from such a situation is that those angles, if we have adjacent angles being supplementary, those angles we can conclude that they actually form a straight line, meaning this line AOB would be perfectly straight. It will be a straight line. It will be OA. It will be AOB. It will be a perfect straight line. Now, I just want to look at this theorem from a different direction, because remember, a theorem must have a logical structure. It must have reasoning in it. It must make sense. If I were to have, let's say, a line that is given by AOB like that, and I were to have two other lines, let's say a line that goes like that and a line that goes like that, and here I happen to measure angle 1, angle 2, so angle 2 and 3. So these angles here is O1 here, and this would be O2, and this would be O3. It must be evident to you, or you must be able to see that in this situation, we actually can think of it as if we have quadrants. We can think of it as if we have here quadrants like that. So meaning this would be the first quadrant, this would be the second quadrant, third and fourth quadrant. Now we know that the first quadrant here is 90 degrees and the second quadrant here is also 90 degrees, meaning these two parts here, they must give us a total of 180 degrees, because it's 90 and 90. But now if we have angles that are overlapping like this, angle 1 being like that, angle 2 being like that, and angle 3 being like that, it is clear to us and really obvious to us that if I were to add angle 1, if I were to say angle O1 plus angle O2 plus angle O3, we will have an angle that is greater than 180 degrees, because from this point here, I will have 180 degrees here. But if I include these two bits here, I will actually be greater than 180 degrees. And definitely we can see that this line where these angles are sitting is not a straight line, because it has a vertex. It actually makes another angle there. So it becomes only a straight line, this line here, when we have 90 here. When we have 180, 90 this side and 90 this side, making a total of 180, that's when this line becomes a straight line. So that's the logic that comes from that theorem, or a way in which we can try to sort of justify the fact that this line should be a straight line, because these angles here, they add up to 180 degrees. it should be clear to you that this theorem actually can be used to prove that a line segment is actually a straight line. So we'll use this theorem if you want to prove that lines are straight lines. So if you are given lines, you know, this piece of a line and that piece of a line, and you want to prove that it's a straight line here, you then have to make sure that these angles, they add to 180, because if they do, then this will be a straight line. If they don't, this can be a straight line. Now, when we solve problems, how we're going to write our reasoning for this theorem is that we will say here that angle O1 plus angle O2 and angle O3, that equals to 180 degrees. Now, always when we write statements, we have to give reasons. Why do we say that? Well, the reason here is because this is the given information, is what we start with. We know that we have angles that are adjacent to each other and they add 280 degrees. It's our hypothesis. So we start with it. So the reason will be given. Now, if angles are like that, we can then conclude, we can come up with a conclusion to say the line AOB must be a straight line. You know, this line AOB must be a straight line. But then we have to provide a reason to say, why are we saying it must be a straight line? Well, because we know this here, because we applied the theorem that says adjacent angles, if adjacent angles are supplementary, then they form a straight line. So that's the theorem that helps us to actually make this conclusion that that line is a straight line. Is what we call the reason, or we say we are applying the theorem that we make conclusions from.